Hi, this is Mrs. LaBarbara. This is Physics Chapter 4, Two-Dimensional Motion and Force, Video 7. Today's topic is force on an inclined plane. The objectives are to know the forces and their directions on an object on the inclines, to understand how to break down weight into parallel and perpendicular components, be able to determine the effects of changing the angle of an incline on the normal force and friction force, and be able to solve problems involving object on an incline. Forces on the object on the incline. So here is a free body diagrams that on the boxes moving on the incline. The first case is moving up the incline. In this case, you have gravity, normal force, friction force is downward, is opposite of UV. When the object moves down the incline, the friction is upward, opposite of V. Again, you'll have your normal force is perpendicular to the incline, and gravity is always down, straight down. So objects accelerate down the inclined plane because of unbalanced force. It doesn't matter the object moving up or moving down, the acceleration is always downward. The unbalanced force is provided by gravity. Note, the normal force is not directed in the direction we're accustomed to, like straight up. The normal force is always directed perpendicular to the surface that the object is on. Now, Fg, or weight, or gravity, we have both names, has two components on the incline. Excuse me. The process of analyzing the forces acting upon objects on an inclined plane will involve resolving the weight vector or gravity into two perpendicular components. One is parallel to the incline. This one, parallel to the incline, people get confused with x-axis. This is not x-axis. Okay, this is the direction that's parallel to the incline. How do we find parallel to the incline? The components parallel to the incline equals Fg times sine theta. This is why this theta right over here, that's the angle of the incline, and this theta are the same. You can use geometry to prove it. This F parallel is opposite of this angle, opposite. Opposite is sine. That's why parallel equals Fg sine theta. Again, this is parallel. This is not x direction, okay? All the parallel components, including frictional force, also parallel to the incline, right? They add together to give you the net force, which should be directed along the incline, either up or down. So this is the direction that's called the parallel direction, parallel to the incline. The other one is perpendicular to the incline. A lot of people get confused. They think perpendicular is the y direction. It's not y direction. We call that perpendicular to the incline, okay? So perpendicular to the incline is this direction, perpendicular. This one, or this side, they're the same. That is adjacent to this angle, to the angle of the incline. They are the same angle. And therefore, F perpendicular equals Fg cosine theta. And this usually cancels out the normal force because the object is not moving perpendicular to the incline. Let's take a look at this example. Component of weight. The diagram below shows a 1.0 times 10 to the 5th Newton truck at rest on a hill that makes an angle 8 degrees with a horizontal. What is the component of truck's weight parallel to the hill or parallel to this incline? Remember the parallel component is the opposite of this 8 degrees. So it's a sine. This parallel is the opposite of the 8 degrees. Parallel equals Fg sine theta. So you plug everything in, you should have 1.0 times 10 to the 4 newtons. Now, as the angle of the incline increases, as you can see 3 pictures, as the angle increases, what happens to Fg? Fg doesn't change, weight doesn't change, doesn't matter where, as long as it is on Earth's surface, okay? But F parallel increases. See, F parallel is smaller, medium, biggest. and F perpendicular decreases. So F normal force also decrease. That means F friction also has to decrease. That means net force is F parallel and friction together. So net force has to increase, acceleration increase. That kind of coincide with what we know in everyday life, right? As you increase the incline, the object is going to speed down, move down faster. This is why, because the components, parallel component increases and friction decreases. Let's take a look at a constant speed in this example. Free body diagram shows the force acting on a 50 Newton crate. When you see 50 Newton, that's indicated the weight of the crate is 50 Newtons. It's sliding down a 30-degree incline, the plane at constant velocity. Here is a keyword, constant. Constant velocity means equilibrium, means all the forces cancels out. Okay, so here is the weight, normal force, and frictional force, 3 forces, right? And this gravity has 2 components, perpendicular and parallel. Because this is a case of equilibrium, that means force friction has to be equal to parallel, normal force has to be equal to perpendicular. So what is the magnitude of normal force? Normal force equals to Fg perpendicular. Fg cosine theta, 50 times cosine 30 give you 43.3 newtons. The magnitude of frictional force, that is F parallel, which is Fg sine theta, which give you 25 newtons. Take a look at another example, accelerating down the incline. So free body diagram shows the force acting on 100 kilogram crate. So this time give you the mass instead of gravity. That is sliding down the inclined plane. The plane is inclined at an angle 30 degrees. The coefficient of friction is 0.3. Determine the net force and acceleration of the crate. So in order to solve this problem, the first step is to draw a free body diagram. So let's do the coordinates. Here is a parallel that's going down as positive, and this is perpendicular going up as positive. Then we can resolve this gravity into F parallel and F perpendicular. So F perpendicular is F cosine 30, which is 850 downward. This should be negative, right? F parallel should be positive 500 newtons. This equation only give you the magnitude because from the diagram you can see it's downward. So in perpendicular direction, since the box is not moving in the perpendicular direction, normal force and F perpendicular should be the same. So normal force equals 850 newtons. Now in parallel direction, there are 2 forces, F parallel and F friction. So the net force should be F parallel minus friction because parallel is down, friction is up. Friction equals mu times F normal. So parallel is 500 minus 0.3 times 850. So you have F net is 235 newtons. Once you know the net force, you can figure out the acceleration. Acceleration is net force divided by mass. Again, mass told you already is 100 kilograms. So you have 2.35 meters per second squared going down the incline. Okay, another example for acceleration down the incline. So 8 Newton block is accelerating down a frictionless ramp, inclined at 15 degrees with horizontal. As shown in the diagram below, what is the magnitude of net force causing the block to accelerate? So here are the free body diagram. You have Fg and Fn, that's it, the 2 blue ones. Now Fg is the force at an angle, so we change Fg into F parallel and F perpendicular. As you can see, F perpendicular and F normal cancels because the block is not moving perpendicular to the incline. So that gives us the net force equals to F parallel. F parallel is mg sine theta. So 8 times sine 15 degrees, you have 2.1 newtons. Let's take a look at example of a constant velocity down the incline. Constant means equilibrium, right? A book weighs 20 newtons, that's a weight. Slide down at a constant velocity down the ramp incline at 30 degrees to the horizontal is shown in the diagram. What is the force of friction between the book and the ramp? So it tells you there is friction force. Again, draw a free body diagram. So here is the weight, there is friction force and normal force. So the black, blue, and the yellow, those are the three forces. Since here is the coordinate, right? Parallel to the incline, perpendicular to the incline. So Fg, we change that, erase that, we change that into F parallel and F perpendicular. Now, because it's moving at a constant velocity, so friction force and the parallel has to be equal to each other. So friction equals to F parallel equals to mg sine theta. Friction equals to 20 times sine 30 gives you 10 newtons. We can also find what F normal is, but it didn't ask that. So I'm just going to stop here. Gives the friction. That's what they're asking you to do. Okay, take a look at another example. A block weighing 10 newtons is on the ramp incline at 30 degrees to the horizontal. A 3 Newton force of friction acts on the block as it is put up the ramp at a constant velocity. This is keyword. Constant velocity means all forces cancels, which is parallel to the ramp. The force is parallel to the ramp as shown. What is the magnitude of force F? So again, let's do the free body diagram. So besides upward applied force and the frictional force, you also have normal force and gravity. Again, this gravity can be changed into F parallel and F perpendicular. Now, because the book is moving at a constant velocity, so all the forces cancel out. That means this upward F has to be equals to downward friction plus F parallel. Friction is 3, F parallel equals to mg times sine 30. mg gives you 10 newtons, so 10 times sine 30, that's 5. So 3 plus 5 is 8 newtons. We can also find a normal force, but it didn't ask the normal force, so we're just going to stop here. F equals 8 newtons. That's it for today. Thanks for watching. See you next time.